All right, today we are working with inequalities and distributing. So let's jump right into it. So for our TEK, or our skill that we want to make sure we cover for Algebra 1, for the STAR test is 5B. Solve linear inequalities in one variable, including those for which the application of distributing property is necessary, for which variables are included on both sides. So you'll see us work through problems today, or see me work through problems today with variables on both sides using distributing. And it's really that simple and basic, but let's go ahead and jump into it. So you remember solving for an equation, right? If you had a basic equation, we had something like, let's say 2x equals 10. And we'll solve, when we say look for the solution for this, we'll say, well, x must equal 5, right? Because 2 times 5 equals 10. But what if you had a situation like this where x is greater than 3? What are the solutions? You notice I said plural solutions because now it can be all numbers greater than 3. So 4, 5, 6, 3.1. Now in this case it can't be 3 because it's not equal to, but everything after that it can. So if I were to put on a number line, it will look like this. It would be all numbers from 3. And a lot of times we'll write a circle. You can draw this little parentheses sign, or you can do it. Most of the time we'll use an open circle and shade in everything this way to suggest that all answers greater than 3. That's the idea of an inequality. It's not equal to, but necessarily, but everything greater than or less than. In this case, greater than. So how do we solve with inequalities? That's really what we want to get into today. So let's jump straight there. It's just like when you're having an equal sign. The only difference is, or one of the main differences I should say, is when you divide by a negative or multiply by a negative, it changes the direction of the sign. But we'll get to that later. Let's go ahead and jump into it here. Most of the time when you're dealing with inequalities, you're going to have multiple steps. Now you're going to use the same rules and steps that you would for solving multi-step equations that were not inequalities. So in this case, I want to get all my variables on the same side. I could do that by, in this case, subtracting 9m. So subtracting 9m on both sides of that inequality leaves me with negative 5m is less than or equal to 17. Just a real quick note how to read this sign, right? So some of us have been taught to read this sign that if the mouth opens to the greater number, and that's true. Please read it that way. So there's two ways you can read it though. You can read it from the left or right, but just make sure you're reading it properly. In this case, how would I read this? I would say negative 5 is less than. Why? Because the mouth is pointing away from the negative 5m, so it must be less than or equal to 17. But I could read it the other way and say 17 is what? Greater than. Why? Because the mouth is open that way. So that makes sense. Now let me write just a really quick note. So let me do something really basic, right? 2 is greater than 1. So now we know what the answer is. 2 is greater than 1. 2, that mouth is open to the 2. We can say 2 is greater than 1. We can also 1 is less than 2. Both answers are right, but please get used to reading them both ways because that is definitely going to continue to come up as we're working through our algebra course. All right, so from this point, we're going to need to divide both sides by a negative 5. Now, notice I said a negative 5, and we're dividing by a negative, so that changes the direction of this sign. So now negative 5, that's m. So instead of this saying less than or equal to, now this becomes greater than and equal to 17 over negative 5. Negative 75. And it doesn't matter if that negative goes on a 5 or this fraction. It's all the same answer. So that's my answer here. That doesn't look pretty. Let's try that again. There we go. All right, so anything that's greater than negative 17 over 5 would be the right answer that will make this inequality true. All right, let's try this one now. See, this one didn't involve distributing, but we had to get through some basic understanding. So now let's use distributing. Same idea. This time we're just going to distribute. So I'm going to say, I noticed that my 3 and p minus 12 needs to be distributed. So I'm going to rewrite everything. I'm going to do 8p, and then I'm going to distribute here, which is going to give me a 3 plus 3p minus 36 is greater than 7p minus 28. And now look, we're back to this basic problem where you don't have any parentheses or distributing. So let's just combine like terms. 8p and 3p gives me an 11p. and nothing else changes, I'm going to get my p's on the same side by subtracting 7p. Now you can subtract 11p, it doesn't matter as long as you do the same thing on both sides, but I'm going to subtract 7p. Alright, so 11 minus 7 leaves me 4p minus 36 is greater than 7p, and 7p go to 0, and I'm left with a negative 28. I want to get rid of 4 and negative 36 because I only want p by itself. I'm going to add 36 on both sides. That leaves me with 4p is greater than negative 28 and 36. If you struggle with these, draw a number line just to get the visual idea, or just use your calculator. By this point, you have a calculator to use. So don't. I've seen students try to make a guess here. No, draw a number line and literally count. So if you had a number line and you just kind of thought to yourself negative 28, and I'm adding 36. So this is 0. So if I add 28 here, that gets me to 0. Well, I need to add 36. So how many more is that? I need to add, let's see, 8 more. So 8 more, well, obviously it's going to give me to the number 8. So in my head, I can think, oh, that's just going to give me the 8. All right, divide both sides by 4, and p is now greater than 2. Notice I didn't have to change the direction of the sign. If I add or subtract, if I subtract something, you don't have to change. But if you're multiplying by a negative or dividing by a negative, that's when we needed to change the direction of that sign. All right, solve these inequalities. This was pretty straightforward. This doesn't have any distributing, so we're going to continue to refine that skill. So I'm going to get subtract 7 on both sides. This leaves me with negative 4. Q is greater than or equal to negative 23. Oh, that's not a pretty number. I was hoping that'd be 24. I almost want to just change it, but I'm not. So let's see, I did everything else right. Yeah. So negative, divide by negative 4. And now it's going to give me Q is greater than or equal to 23 over 4. But I didn't do that right, did I? Because we divided by a negative. So what has to happen with this sign? So this sign actually needs to go, let me go back a little bit. This sign actually needs to go the other direction and make it less than or equal to 23 over 4. And there we go. And why does it change anyway? Why does this sign change? If you care, I was curious, why does that change? So if we go back to like a typical problem, 3 is, 3 is less than 5. Or 5 is greater than 3. Let's start with there. Why does the sign change when you multiply both sides by a negative or divide by a negative? So what if I multiply both sides by a negative 1 here? So what if I multiply this by negative 1 and this by negative 1? So this negative 1 and multiply this by negative 1. What would I get? Well, this is just negative 5 now, and this is a negative 3. So it changes the numbers, right? So what does that have to do with the sign? Well, you can no longer keep that sign as negative 5 is greater than negative 3, because negative 5 we know is not greater than 3. That is not a bigger number. So the sign actually has to change now to the other direction. That's why you change the sign. It's not just a rule you have to remember. You can actually come up with a test and do it yourself, and to remind yourself that's when I change the sign. Same thing is going to happen when I divide. All right, now let's go ahead and go to this one and distribute. That's the first thing I jump to. 2y plus 12 greater than 5y minus 24, and don't forget your 9y in the beginning. So combining like terms, 9 plus 2 gives me an 11y plus 12 is greater than 5y minus 24. I want to get my y's on the same side, and I'm going to do that by subtracting 5y, and that leaves me with 6y plus 12 greater than negative 24. Now I'm going to get my y by itself. The first thing I'm going to do is subtract 12. That leaves me with 6y is greater than a negative 36. Divide both sides by 6, not a negative 6, but a positive 6. Even though this number is negative, we don't have to do anything. We divided by a positive 6. So nothing changes here. We just get negative 6. Now, if we divide it by a negative 6, it would change the sign. It depends on the let's see, the divisor by which you're divising by, not the dividend. So that's going to stay the same. All right, let's quickly go through these. And I want to encourage you to work this yourself as I go through. I know I'm picking up the pace a little bit. Notice that both sides have distributing properties. This is just something you got to get used to. A lot of steps, easy to mess up because there's so many steps. So you got to take your time with it. So let's start with this one, 8x. I'm distributing here, it gives me a negative 10. If I keep going, it gives me a positive 2x, all right, because negative 2 and negative x. And over here, if I distribute, I got a less than 4x, all right, and then plus 36 plus 6x. I'm going to combine my like terms to get 8x and 2x gives me 10x minus 10 is less than 4x and 6x gives me 10x plus 36. Now I can see that something interesting is about to happen because you see a 10x and a 10x on both sides, and I need to get them on the same side. So what's going to actually happen here? Let's see, minus 10x, and now I'm left with a negative 10 less than 36. So in this case, what we have is that it's going to be all, since this is a true statement, that negative 10 really is less than 36. It can be all real answers. So x is all real numbers. So it could be any number. Any number you put here is going to make this true. It's going to make this side less than this side. And that's why we're coming up with it looking this way. All right, let's jump to this last problem before we get to our star problems. 4b is and we got negative 9 distribute here. We get a negative 3. I'm sorry, positive 3b is greater than 5b and negative 30 because we distribute here, and plus 2b. I know that looks like a 6, so I'm trying to make sure I say b. Combine our like terms. 4 and 3 gives me a 7b minus 9 is greater than, combine my like terms, 5 and 2 is 7b, and I have a negative 30. So look, I have this again. I can see that these are going to cancel out. So let's go ahead and make that happen. So we're going to say subtract 7b to get those on the same side. Now they're gone. Now we have negative 9 is greater than negative 30. So again, is this a true statement? Is negative 9 greater than negative 30? Well, negative 9 is greater than negative 30 because on the number line, if you remember, we have a negative 9 here, a negative 30 here, and 0 here. So it's actually closer to 0. Negative 9 is closer to 0. So this is a true statement. So x can be any number, any real number that's going to make this true. So those are kind of interesting when you get that. Now, obviously, if it were the other way around, it can't be anything. There's no number you put there will make that true. So I just want to present those to you because sometimes that does come up. Now, what does this look like on star? How will we be tested on this? So back in 2016, here's how one of the problems that came up. And this is pretty straightforward, right? So you can just multiply both sides here to get 15 minus 5x is less than negative 2x plus 6. Get your x's on the same side by adding 2x. And that leaves me with 15 is, what is that? Negative 5 and 2 minus 3x is less than 6. I want to get my x by itself, so I'm subtracting 15. Leaves me with negative 3x is less than negative 9. Divide by a negative 3. Remember, dividing by a negative 3 is going to do what? Change the sign the other way. So now I get negative 9 divided by negative 3 gives me a positive 3. Now x is greater than 3. So that's one way I could do it. Now we could also check to see if we did this correctly. I know I just erased it all, but we know that our answer was x is greater than 3. So we can check and see if this is right. If I put numbers in here greater than 3 to see if that makes it true. Let's just try 4. So if I put a 4 there, 3 minus 4 is going to give me a negative 1. Negative 1 times 5 is negative 5. And if I put a 4 here, 4 times negative 2 is negative 8. Negative 8 plus 6 is a negative 2. So is -5 less than -2? This is true. So testing it with 1 or 2 points is a great idea to see if this inequality actually works. You could do 3.5 and such to try to see if this is right. And we just saw that indeed it is correct. Well, that concludes it. We've covered it all. We distributed using inequalities. So solve linear inequalities in one variable, including those for which the application of the distributive property is necessary. We got it done. Hey guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I'll see you next lesson.